Hello, my name is Sawyer West, and today I will present on the basics of proof writing. A proof is a sequence of logical deductions which lead from an assumption to a conclusion. A direct proof is when you start from an assumption and make some deductions to show that the conclusion must follow. A contrapositive proof is when you suppose the conclusion is false, and then make deductions to show that the assumption must also be false. A proof by contradiction is when you suppose the negation of what you are trying to prove, and then you assume the assumption. Then, you make deductions to find a contradiction. This is a truth table. It is a tool used to prove statements about truth. In each row, we make different assumptions about what statements are true, and in each column, we determine if a proposition is true or false given the assumptions. In the table, every combination of assumptions is accounted for. Observe A implies B is true whenever A is false, because when A is false, we are making no assertions about the validity of B. We can use contrapositive proofs to prove propositions because its column values are equivalent to that of a direct proof. Observe that the column values of a proof by contradiction are the same as those of a direct proof. Let's look at an example of a proof. Consider the set of non-negative integers. For any even element n in this set, does its square have the same parity? Suppose we have an even non-negative integer. Since n is even, it has the form 2k, where k is some other non-negative integer. Observe n squared is 4k squared, which equals 2 times 2k squared, which is by definition even. Alternatively, we could write a proof with only algebra which uses the exact same line of reasoning. However, this purely algebraic proof is unnecessarily hard to understand. The difference in clarity between purely algebraic proofs and nice proofs grows with complexity. Proofs should be clear and concise. Algebra and language are both useful tools for describing the abstract. When writing proofs, use the tool of least resistance. Nice proofs should flow like water. Remember, you are writing. Do not forget to use grammar, punctuation, spelling, good writing style, and a diverse vocabulary. Let's look at a problem I saw on a physics exam written by Professor Milne at St. Mary's College of Maryland. We will use proof writing to provide a solution to the problem. Suppose you are standing on the roof of a building with two identical ping pong balls. We will assume air resistance is negligible and gravity is constant. You drop one ball, and 1 second later you drop the second ball. Will the first ball land exactly 1 second before the second ball? Pause the video and consider how you would prove the proposition. We know the following information. There are two identical objects with different release times and an initial velocity of 0. We also know the only force acting in the system is gravity. Furthermore, there are some physics tools regarding motion in one direction we can use. Pause the video and consider how you would prove the proposition. We will write a proof by contradiction. Suppose, for the sake of contradiction, ball 2 does not land exactly 1 second after ball 1. Thus, ball 2 covers the same distance as ball 1 in a shorter or longer period of time. This implies that the balls have different average velocities because the change in position is equal to the average velocity times time. Furthermore, the final velocities of the balls must be different because their initial velocities are both 0, and the average velocity is the average of the initial and final velocities. This means the change in velocities of the balls are not equal. Since any change in velocity is caused by a net force, and the only force in the system is gravity, we must conclude gravity is not constant, because force is mass times acceleration. However, we assume gravity is constant. Therefore, we have a contradiction and it must be the case that ball 2 lands exactly 1 second after ball 1. Let's look at the structure of the proof. Note we could have chosen to write a direct or contrapositive proof instead of a proof by contradiction. This would change the structure of the argument and require a different line of reasoning. However, it would still be a valid proof. Observe that 1/3 of the proof is the crux of the argument. This is the part that requires problem solving. The rest of the argument requires we have an understanding of what the proof is asking and an understanding of how to set up and conclude a proof. In the assumption section, we reworded our initial statement such that we were not working with a negation. Negated statements are always difficult to start an argument with. In the contradiction section, we reworded the question to conclude the proof. Let's take a closer look at the crux of the argument. We started with a piece of information and used a tool of deduction to generate a new piece of information. In this example, the tools of deduction were one-dimensional motion equations. This argument consisted of 5 logical steps. I want to thank my sister Sydney West for helping me edit the presentation. Thank you for listening.